Hello students, in this video we'll be seeing about solutions for previous year question papers of NEET Physics. So particularly we'll be focusing on the topic wave mechanics. So before going inside the topic, let us have a statistical analysis about the previous year questions, like how many questions were coming from different subdivisions of wave mechanics. So if you have a look, we have around 5 subdivisions in wave mechanics unit. The first one is basics of mechanical, progressive and stationary waves. Second one is principle of superposition of waves, and third one is standing waves in string and organ pipes, and fourth one is formation of beads, and fifth one is Doppler effect. So if you have a look, around 32% of questions were coming from basics of mechanical, progressive and stationary waves, and 5% were coming from principle of superposition of waves, and 30% of questions were coming from standing waves in string and organ pipes, and 16% of questions were coming from formation of beads, and 3% of questions were coming from Doppler effect. So this is the scenario for the past 33 years, and majority of questions were coming from in these two major topics, basics of mechanical, progressive and stationary waves, and standing waves in string and organ pipes. And next, formation of beads, around 16% were coming. So these three topics were having a prior importance in the past 33 years. Whereas if you see in the last 8 years, the scenario is quite changed. Around only 5% were coming from basics of mechanical, progressive and stationary waves, and around 65% of questions were coming from standing waves in string and organ pipes, and 10% from formation of beads, and 20% from Doppler effect. So the majority of questions were coming from the standing waves in string and organ pipes, and the next majority was given to Doppler effect. 20% of questions were coming. So what we'll be doing in this video is we'll try to cover all the subtopics, and we'll try to solve different sample problems covering each and every subtopic. In particular, we'll be solving the previous year question papers, previous year questions which were asked from all these subdivisions, and we'll be giving more importance to these two topics, standing waves and string and organ pipes and Doppler effect, because more number of questions were coming from these particular topics in the last 8 years. Okay, so let us go on to the first question. A wave traveling in the positive x direction, having displacement along y direction as 1 meter, wavelength 2 pi meter, and frequency of 1 by pi hertz is represented by. Okay, so they given some equations here. So you all know the general equation, y is equal to a sine k x minus omega t. Okay, so here k is equal to, how much they have given is k is 2 pi by lambda. Okay, so the wavelength they've given it as 2 pi, so 2 pi by 2 pi, so this will become 1, and omega is equal to 2 pi n, and here n value, the frequency they have given it as 1 by pi, so it is there in the question, so you're going to substitute here 2 pi into 1 by pi, so this will become 2. Okay, so you're going to substitute this values here, and a value they have given it as 1, so y is equal to, so a will become 1 sine x minus 2t, because k value is 1 and omega value is 2. So the final value is x minus 2t. So the correct answer is option number 1. Okay. So y is equal to sine x minus 2t. Here they have given you the k value. Sorry, they have given you the lambda value. So you can easily find out the k value by 2 pi by lambda, and omega is 2 pi f or 2 pi n, where n is a frequency, and again n they are given it as 1 by pi. So you're substituting, so you'll be getting the value of omega as 2 and a is 1. So you're just substituting all these values, so you'll be getting the equation as y is equal to sine x minus 2t. The next question is the equation of a simple harmonic wave is given by y is equal to 3 sine pi by 2 50t minus x, where x and y are in meters and t is in seconds. The ratio of maximum particle velocity and wave velocity is. So here they want us to calculate the maximum particle velocity, and they also want us to calculate the wave velocity. Okay, so first thing is write down the equation. Y is equal to 3 sine pi by 2 50t minus x. Okay, so you are taking this pi by 2 inside, it will become 3 sine 25 pi t minus pi by 2 x. Okay, so now you are comparing it with the general equation. Y is equal to a sine omega t minus kx. Okay, so if you compare these two, you can easily find out omega is equal to 25 pi and k is equal to pi by 2. Okay, so now you can easily find out the wave velocity. Wave velocity is given by v is equal to omega by k, so which is equal to 25 pi by pi by 2. So pi and pi will get cancelled, so v will become 50 meter per second. So this is the wave velocity. Now you can easily find out the particle velocity. Particle velocity is given by Vp is equal to dy by dt. Okay, so what you have to do is you have to differentiate this equation. So this will become d by dt of 3 sine 25 pi t minus pi by 2 x. Okay, so you are going to differentiate this. So if you differentiate this, you will be getting it as 75 pi cos 25 pi t minus pi by 2. Okay, so here the maximum is cos term becomes 1, so Vp maximum, particle velocity maximum, will become Vp max is equal to 75 pi. Okay, but as per the question, you want the ratio between maximum particle velocity to the wave velocity. So Vp max by V is equal to 75 pi by 50. So this will be 3 by 2 pi. So the correct answer is option number 2. So the ratio of particle velocity to the wave velocity is 3 by 2 pi. So you can easily find out the ratio by first finding out the wave velocity and then finding out the particle velocity by differentiating with respect to time. Okay, so then you are going to take the ratio. So it's a very simple sum. Let us now move on to the next question. Sound wave travels at 350 meter per second through warm air and at 3500 meter per second through brass. The wavelength of a 700 hertz acoustic wave as it enters brass from warm air is. So they want us to find out the wavelength. V is equal to n lambda, as frequency is same in both the medium. V is equal to n lambda. Since frequency is same in both the medium, V is directly proportional to lambda. So here what they are trying to say is they are saying that the wavelength is increasing. So what about the factor, how it is going to increase? Either it will decrease or increase. So here what happens is since the wavelength is increasing, since the frequency is increasing, or sorry, as the frequency is same in both the mediums, since V is increasing 10 times, lambda also will be increasing around 10 times. Okay, because you can see the sound wave is 350 through warm air, and when it is traveling through brass it is 3500. Okay, so it is around 10 times increasing. And as you can see from this equation, V is directly proportional to lambda. So the velocity is directly proportional to the wavelength. So ultimately what happens is when V is increasing 10 times, lambda will also increase by a factor of 10. So the correct answer is option number 4. Okay. So let us now move on to the next question. Two waves are represented by the equation y1 is equal to a sine omega t plus kx plus 0.57 meter, and y2 is equal to a cos omega t plus kx meter, where x is in meter and t is in second, the phase difference between them. Okay, so write down the equations first. Y1 is equal to a sine omega t plus kx plus 0.57. Okay, so pi 1 is equal to omega t plus kx plus 0.7. So this is pi 1, and similarly y2 is equal to a cos omega t plus kx, a cos omega t plus kx. So you can change it into sine by writing this a sine omega t plus kx plus pi by 2. Okay, so I can change it to sine. Now pi 2 is equal to omega t plus kx plus pi by 2. Okay, so here you want to find out the phase difference. Del pi is equal to pi 2 minus pi 1. Okay, so this will become omega t plus kx plus pi by 2 minus omega t plus kx plus 0.57. Okay, so we are writing this factor pi 1 here and pi 2 here. So these terms will get cancelled because of the negative sign, so it will become pi by 2 minus 0.57. Okay, so when you solve this, pi by 2 is 1.57 minus 0.57, so this will become 1 radian. Okay, so the phase difference is 1 radian. The correct answer is option number 1. So you are writing the two equations, y1 equal to a sin omega t plus kx plus 0.7 and y2 is equal to a cos omega t plus kx. So you are converting into sin by adding a pi by 2. So a sin omega t plus kx plus pi by 2. So the inner term is pi, and here the inner term is pi 2, and you are subtracting both things in order to get the phase difference. So the phase difference value is 1 radian. Okay, so let us now move on to the next question. A transverse wave is represented by y is equal to a sin omega t minus kx. For what value of the wavelength is the wave velocity equal to the maximum particle velocity? So here they have given the equation as y is equal to a sin omega t minus kx. Okay, so that in the previous problem we saw wave velocity is given by v is equal to omega by k. Okay, and particle velocity Vp is dy by dt. Okay, so if you differentiate that, you will be getting it as a omega cos omega t minus kx. Okay, so you are differentiating it, and that the maximum particle velocity will become is a omega. Okay, so here what they have given is for what value of wavelength is the wave velocity equal to the maximum particle velocity. So that is, they are saying that v is equal to Vp max. Okay, that's what they are saying. So omega by k is equal to a omega will get cancelled, and we all know that k is equal to 2 pi by lambda. So this will become lambda by 2 pi is equal to a, or lambda is equal to 2 pi a. Okay, so the correct answer is option number 3. So for lambda equal to 2 pi a, the particle velocity will be equivalent to the wave velocity. Sorry, the maximum particle velocity will be equivalent to the wave velocity. Okay, it's a very simple problem. Just you are taking the general formula y is equal to a sin omega t minus kx, and you are differentiating with respect to dt, so that you will be getting the particle velocity, and you are taking the maximum particle velocity value, and as per the condition you are equating the wave velocity and the maximum particle velocity. You can easily find out the lambda value. So lambda is equal to 2 pi a is the correct answer. Option number 3 is correct. Okay, so let us now move on to the next question. Two periodic waves of intensities I1 and I2 pass through a region at the same time in the same direction. The sum of the maximum and minimum intensities is. Okay, so here I max is equal to I1 plus I2 plus 2 into root of I1 I2, and I minimum is equal to I1 plus I2 minus 2 into root of I1, I2. Okay, so what they're asking is, they're asking the sum of maximum and minimum intensities. Okay, so if you just add these two, you will be getting as I1 plus I2 plus 2 into root of I1 I2 I1 plus I2 minus 2 into root of I1 plus I2. So these two terms get cancelled, so it will become 2 I1 plus I2. So the correct answer is option number 2. The sum of maximum and minimum intensities is 2 of I1 plus I2. Okay, so let us now move on to the next question. A point source emits sound equally in all directions in a non-absorbing medium. 2 points P and Q are at a distance 2 meters and 3 meters respectively from the source. The ratio of the intensities of the wave at P and Q is. So here they are telling that a point source is emitting sound equally in all the directions in a non-absorbing medium, and 2 points P and Q are at a distance 2 meter and 3 meter respectively from the source. The ratio of the intensities of the sound waves at P and Q is. So we all know that intensity is inversely proportional to the square of the distance. Okay, so I1 is inversely proportional to 2 square. Why 2 is because it's 2 meters. One P is at 2 meters, and next one is I2 is inversely proportional to 3 square. Okay, so what they are telling us, they want us to find out the ratio of the intensities of the waves. Okay, so I1 by I2 is equal to, what happens is, this is 1 by 9 and this is 4, so it will become 9 by 4. Okay, so the correct answer is option number 3, 9 is to 4. So 9 by 4 is the correct option. So we know that intensity is inversely proportional to the square of the distance, and I1, the two distances they given, 2 and 3 meters. So two different distance from the source, 2 meters and 3 meters, you are squaring it and you are taking the ratio of it. So I1 by I2 is equal to 9 by 4. Okay, so it's a very simple problem. Now let us move on to the next question. The length of a string of a musical instrument is 90 centimeters and has a fundamental frequency of 120 hertz. Where should it be pressed to produce fundamental frequency of 180 hertz? So here the frequency of the stretched string, frequency of stretched string is given by n is equal to 1 by 2 L into root of T by M. Okay, so we know that n is inversely proportional to the length because T and M are constant. Okay, so n dash by n will be equal to L by L dash. Okay, so here they have given you the two different frequencies. One is 120 hertz and another one is 180 hertz. Okay, so n dash is 180 hertz and n is 120 hertz, and the length they have given us L as 19 and they want us to find out L dash. Okay, so you're going to substitute it here. So 180 by 120 is equal to 90 by L dash. Okay, so this you get, it will become 2, and this if you cancel, this will become 60. So L dash will become 60 centimeters. Okay, so the correct answer is option number 3. So it's a very simple problem. You are going to use the formula for the frequency of a stress strain, which is equal to n is equal to 1 by 2L into root of T by M, and since T and M are constant, we are considering n is inversely proportional to the length, that is frequency is inversely proportional to the length. And if you take the ratio of the frequencies, two different frequencies, it will become n dash by n is equal to L by L dash. Okay, so two different frequencies they have given, you are going to substitute and you are going to easily find out the another length, that is where you have to press it, at which length you have to press it in order to produce a frequency of around 180 hertz. So you need to press it around 60 centimeters. Okay, so let us now move on to the next question. A tuning fork with frequency with 800 hertz produces resonance in a resonance column tube with upper and open and lower end closed by water surface. Okay, so that is upper end is open and the lower end is closed by water surface. Successive resonance are observed at lengths 9.75 centimeter, 31.25 centimeter, 52.75 centimeter. The speed of sound in air is, so you know the speed of sound is given by 2v is equal to 2f into L2 minus L1. Okay, so here they have given the L1 value as 9.75 and L2 value as 31.25. Okay, so L1 is 9.75 centimeters, or you can change it to meters, 0.0975 meters, and L2 is 31.25 centimeters, or you can change it to 0.312 meters, and frequency they have given it as 800 hertz. So you substitute this in this formula, you are getting 2 into 800 into 0.312 minus 0.0975. Okay, so if you solve this, 2 into 800, 0.215. Okay, so if you solve this, you will be getting the V value as 344 meter per second. So the correct answer is option number 4, 344 meter per second. Okay, so it's also a very simple formula substitution. We are taking the speed as V is equal to 2f L2 minus L1, and all the values they are given. They are given the frequency value, they are given the successive resonance length at which resonance is observed, 9.75, 31.25. So L1 and L2 values are given. You are going to substitute it and you are going to find out the speed of sound in air. Okay, so it is V is equal to 344 meter per second. The correct answer is option number 4. Okay, so let us now move on to the next question. The fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe. If the length of the closed organ pipe is 20 centimeters, the length of the open organ pipe is, okay. So here the fundamental frequency of open organ pipe is given by N1 is equal to V by 2L0. Okay, so frequency of third harmonic for closed organ pipe is given by N2 is equal to 3V by 4 LC. Okay, so this is LO is for open and LC is for closed. Okay, so here they are giving you a condition that both are equal, that is the fundamental frequency of open organ pipe is equal to the third harmonic of a closed organ pipe. So N1 is equal to N2, they are given this condition, so this will automatically become V by 2L naught is equal to 3V by 4 LC. Okay, so and another thing is V and V will get cancelled. Here, if the length of the closed organ pipe is 20 centimeter, the length of the open organ pipe will be how much? Okay, so LC value they have given it as 20 centimeters. Okay, so it will become L naught is equal to 4 LC by 6, or it is 4 into 20 by 6. Okay, so this will become 2 and this will become 3, so this will become 40 by 3. So if you solve this, you will be getting it as around 13.33 centimeters. Okay, so the correct answer is option number 1, 13.2 centimeters. So it's a very simple formula substitution only. You are taking the fundamental frequency of open organ pipe and you are taking the fundamental frequency of third harmonic of a closed organ pipe and you are equating it. All other values they have given. Okay, so they have given the values of length of open organ, they want us to calculate the length of open organ pipe. They have given the value of the length of closed organ pipe and you are just substituting and you are finding out the LS 13.33 centimeters. So the correct answer is option number 1. Okay, so let us now move on to the next question. A tuning fork is used to produce resonance in a glass tube. The length of the air column in this tube can be adjusted by a variable piston. At room temperature of 27 degrees Celsius, two successive resonances are produced at 20 cm and 73 cm of column length. If the frequency of the tuning fork is 320 Hz, the velocity of the sound in air at 27 degree Celsius is okay. So here for a resonance tube experiment, difference between the length of column for two successive resonances is given by L n plus 1 minus Ln is equal to lambda by 2, or it is V by 2n. So V will become 2n Ln plus 1 minus Ln. Okay, so 2 into the frequency is 320 into, and here they have given the Ln values 73 and 20 centimeters. Okay, you're converting it into meters, so you're putting it as 0.73 minus 0.20. So if you solve this, you will be getting the value as 339.2 meter per second. Okay, so the correct answer is option number 2, 339 meter per second. Okay, so here what you are doing is, for a resonance tube experiment, the difference between the length of the column for two successive resonances is given by L1 Ln plus 1 minus Ln equal to lambda by 2. So you are changing the lambda into the velocity formula, so V by 2n. So here they have given you the successive resonance length 20 cm and 70 cm that you are going to substitute here, and the frequency also they given it as 320 Hz. So you are substituting it and you are finding out the velocity of sound in air. So it is 339.2 2 meter per second. So the correct answer is option number 2. Okay. So let us now move on to the next question. The two nearest harmonics of a tube closed at one end and open at another end are 220 Hz and 260 Hz. What is the fundamental frequency of the system? Okay, so here, as a tube is closed at one end and open at other end, what happens is 2n plus 1 V by 4L is equal to 260 Hertz. Okay, and another one is 2n minus 1 into V by 4L is equal to 220 Hertz. Okay, so this you can take it as equation number 1 and this you can take it as equation number 2. Now what you're going to do is you're going to subtract equation 2 from equation 1. So when you're doing that, what happens is you'll be getting it as 2V by 4L is equal to 40. Okay, sorry, 1 minus 2, it's 1 minus 2. So 2V by 4L is equal to 40, or the fundamental frequency will become V by 4L is equal to 20 Hertz. So the correct answer is option number 2. So the fundamental frequency of the system is around 20 Hertz. Okay, so let us now move on to the next question. The second overtone of an open organ pipe has the same frequency as the first overtone of a closed pipe L meter long. The length of the open pipe will be. Okay, so second overtone of open pipe is third harmonic. So N3 will become 3V by 2L. And first overtone of the closed pipe is third harmonic. So N2 is equal to 3V by 4L. And L dash be the length of open pipe. So this will become 3V by 2L dash is equal to 3V by 4L. Okay, so you want to find out the value of L dash. So L dash will become 3V and 3V will get cancelled. It will become 4L by 2, or it is 2L. Okay, so the correct answer is option number 3. So it is also a simple substitution formula of the open and closed organ pipes. Okay, so let us now move on to the next question. An air column closed at one end and open at other resonates with a tuning fork when the smallest length of the column is 50 cm. The next larger length of the column resonating with the same tuning fork is. So here in a closed pipe, odd harmonics are observed. So lengths for resonance are also in sequence of L1, 3L1, 5L1, like that it goes on. So it goes like L1, 3L1, 5L1, like that it goes. So where L1 is the minimum length of the column with which resonance occurs. Okay, so the next length is given by 3L1. So they have given you the first column length is, smallest column is 50 centimeters. So they want us to find out the next larger length of the column. So this will become next length is 3L1. So this 3 into 50, so it will become 150 centimeters. So the correct answer is option number 1. Okay, so that's what happens in a closed pipe. some odd harmonics is observed. So the length for resonance are also in sequence of L1, 3L1, 5L1 and all. So here they given you the L1 value as 50 and they want us to find out the next larger length. So you have to multiply it with 3. The next one is 3L1. So it become 3 into 50. So it will become 150 centimeters. So the correct answer is option number 1. Okay. So now let us see the next question. In a guitar of two strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hz. When tension in B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530 Hz, the original frequency of B will be. Okay, so here they have given VB is equal to V plus or minus 6. Okay, that is the frequency is changing out of tune and produces beats of frequency 6 Hz. It might be a plus or it might be a negative one. Okay, so VB is equal to VA plus or minus 6 and VB is equal to 530 plus or minus 6. That is, it can be 524 or 536 Hz. Okay, as frequency of the string is directly proportional to the tension root T, where T is the tension, decrease in tension would cause decrease in frequency. So here, since upon decreasing the frequency, the beat frequency increases. So VB will be equal to 524 Hz. Okay, so the correct answer is option number 1. Okay, this is because of the frequency of the string is directly proportional to the tension. So here the decrease in tension would cause decrease in frequency. So you are taking the decreasing frequency, which is 524 Hz. Okay, so now let us move on to the next question. A source of unknown frequency gives 4 beats per second when sounded with a source of known frequency 250 Hz. The second harmonic of the source of unknown frequency gives 5 beats per second when sounded with a source of frequency 513 Hz. The unknown frequency is okay. So here they are saying that a source of unknown frequency gives 4 beats per second when sounded with a source of known frequency 250 Hz. The second harmonic of the sound of unknown frequency gives 5 beats per second when sounded with a source of frequency 513 Hz. Okay, so NA is equal to 250 plus or minus 4 Hz. This is the first one. So NA is equal to 254 or 246 Hz. Next, NB is equal to 513 plus or minus 5 Hz. So NB is equal to 518 or 508 Hz. Okay, so NB is equal to 2 times of NA. So which is 508 is equal to 2 into 254. Okay, so N value will become 254 Hz. So the correct answer is option number 1. So the unknown frequency is 254 Hz. So let us now move on to the next question. Two cars moving in opposite directions approaches to each other with speed of 22 meter per second and 16.5 meter per second respectively. The driver of the first car blows a horn having a frequency of 400 Hz. The frequency heard by the driver of the second car is how much? So velocity of sound is 340 meter per second. So here both source and observers are moving towards each other. Okay, so n is equal to n naught v plus v naught by v minus v naught is equal to 400 into 40 plus 16.5 divided by 340 minus 22. Okay, here they have given you the values already. So v naught is 16.5 and v is 40, so you are substituting it here and you are finding out okay, so this is vs. So if you solve this, you will be getting n is equal to 448 Hertz. So the correct answer is option number 4. Okay, so let us see the next question. A siren emitting a sound of frequency 800 Hz moves away from an observer towards a cliff at a speed of 15 meter per second. Then the frequency of sound that the observer hears in the echo reflected from the cliff is. So here they are telling us to take the velocity of sound in air is equal to 330 meter per second. Okay, so they want us to find out the frequency of sound that the observer observes. So as siren moves towards cliff, frequency of instant on the cliff is given by n dash is equal to v by v minus vs. Okay, so this will become 330 by 330 minus 15 into 800. Okay, so we have one n here, so you are substituting here, and when you are trying to solve this, you will be getting it as 838 Hertz. Okay, so it's a very simple substitution of the formula. N dash equal to v by v minus vs into n, and v value you know it is 330 and vs value is 15. That's what they are given, and the frequency is 800. So you're substituting it here and you're solving it. You will be getting the frequency value as 838 Hertz. So the correct answer is option number 1. Okay, so let us move on to the next question. A source of sound S emitting waves of frequency 100 Hz and an observer O are located at the same distance from each other. The source is moving with the speed of 19.4 meter per second at an angle of 60 degrees with the source observer line as shown in the figure. The observer is at rest. The apparent frequency observed by the observer is, so velocity of sound in air they have given it as 300 meter per second. So here, as the source is moving at an angle of 60 degrees with respect to the observer, in this case Vs is equal to velocity of source into cos 60 degree. Okay, so this will become 19.4. That's what they are given, the speed into cos 60 is 1 by 2. Okay, so now you want to find out the apparent frequency. So the apparent frequency is given by n dash is equal to v by v minus vs. Okay, vs you know it is 19.4 by 2 and v value is 330. So this will become 330 by 330 minus 19.4 by 2. So if you solve this, you will be getting it as around 103 Hertz. So the apparent frequency is 103 Hertz. So the correct answer is option number 3. Okay, so if you notice in Doppler effect topic, majority of questions are dealing with the same formula, and they are asking us to calculate the apparent frequency of the observer or apparent frequency like that. So it is n dash equal to v by v minus s into n value. Okay, I forgot here n. So this will be 100. Okay, so this is the general formula which you are using. So you have to use the same formula for a different set of problems. So you can easily substitute the values whatever they're giving. Just you are going to substitute the values and you are going to find out the answer. So just you have to remember the formulas and you should understand the concept. You have to read the question clearly and then you have to apply the formulas or apply the values in the formulas perfectly. Okay, let us now move on to the next question. A speeding motorcyclist sees traffic jam ahead of him. He slows down to 36 km per hour. He finds the traffic has eased and a car moving ahead of him at 18 km per hour is honking at a frequency at 1392 Hz. If the speed of the sound is 343 meter per second, the frequency of the honk as heard by him will be. Okay, so here they have given it as V0 is equal to 36 km per hour, so which is equal to 10 meter per second. Okay, and Vs is equal to 18 km per hour, so here it is equivalent to 5 meter per second. Okay, so that is from O and it is from S. So we know that n dash is equal to n into V plus V0 by V plus Vs. Okay, so here it become they have given the speed of sound as 343 meter per second and n value they have given it as 1392 Hertz. You know what is the v value and what is the Vs value. Okay, so you are going to just substitute it here. So it will become 1392 into V value is how much? They have given it as 343 plus V0 is 10, 343 plus 5. Okay, so n dash will become 1392 into 353 by 348. So if you solve this, you will be getting it as 1412 Hertz. Okay, so the correct answer is 1412 Hertz, option number 3. So this is also a mere substitution of the formula. They have given you all the values. You are going to just substitute the values in the formula and you are going to find out the frequency of the honk. Okay, so I think this video would have been useful for you to recall some of the sample problems of this particular unit called wave mechanics. So as I was saying you in the initial slides, I would request you to give more importance to topics like standing waves in string and organ pipes, and also Doppler effect, because majority of questions were coming from these two different subtopics. And if you have a look, all the problems which I solved were asked in the previous question papers or previous year exams. They were asking these questions. If you just have a look, all the problems seems to be quite simple, and just have to understand the question in a better way, and you are going to substitute the values in the formula. So what you have to do is first list out the formulas which are relevant to all these subtopics, like basics of mechanical progressive and stationary waves, principle of superposition waves, standing waves in string and organ pipes, formation of beads, and Doppler effect. So just list out all the formulas from all these subdivisions, and try to solve the previous year questions as we did now, so that you will come to an idea. By referring to these formulas, you can match, or you can write those formulas by referring your reference where you have written all the formulas, and you can just see it will be just a mere substitution of these formulas. Okay, so I wish you all good luck for your preparation, and all the best for your examinations. See you in the next video. Thank you.